And we are going to discuss inverse trigonometric functions. We've been talking about straight-on trig functions. Now we're going to talk about their inverses. We want to understand and use the inverse sine function, the inverse cosine function, and the inverse tangent function. We're going to use a calculator to evaluate them, and we're going to find exact values of inverse trigonometric functions. A calculator, for the most part, won't give them to you in exact values unless you've got one of a couple of scientific calculators that will do that for you. But we are going to use algebra to figure out what the exact values are. First thing that we want to talk about, though, is what are we dealing with? Because right now, if we look at this, this is a sine wave, right? Y equals sine of x, or we could write it as f of x equals sine of x, because we know that this is a function. However, that function fails the horizontal line test, which means that it does not have an inverse. Okay? That's what this is doing right here. How many times does that particular line intersect f of x equals sine x? Right. It would be an infinite number of intersections. So the horizontal line intersects y equals sine x at more than one point. So there is no inverse function. Now, so that you get a full understanding of that, when you look at y equals sine x, or f of x equals sine of x, that's what it looks like, right? This is what it would look like if we graphed sine inverse of x. Obviously, that red graph fails the vertical line test, right? And what does the vertical line test tell me, Brat? Yeah, what's the vertical line test tell me? Say that again. Yeah, well, I think, yeah, you're saying it basically, if I draw a vertical line, what happens? It's intersecting it at more than one place. Just like the original function failed the horizontal line test, the inverse is failing the vertical line test, so therefore, what do I know? It's not a function. So, by definition, a function will only have an inverse function if it passes the horizontal line test, which means that the inverse graph has to pass the vertical line test. This red is the inverse graph. It does not pass the vertical line test. So, let's see if I can remember how to get rid of this stuff. There we go. If I do this instead, whoops, that's not what I want. If I restrict my function from negative pi over 2 to pi over 2, does it still fail the horizontal line test? No. Which means that restricted, I will have an inverse function. Does that graph fail the vertical line test? No. So therefore, what we're going to do is we're going to restrict the domain of f of x. So restrict the domain to the following: negative pi over 2 to pi over 2. In other words, if we look at the graph here, we're going to restrict it from right here to right here. And we're just looking at this right here. Well, that's probably a bad color. Let's use this. That's what we're going to talk about when we talk about y equals sine x, when we're dealing with trying to find its inverse. Here's your definition. The inverse sine function, it is denoted by sin with an exponent of -1. It's not really an exponent, it's a superscript. Is the inverse of the restricted sine function y equals sine x. We're going to restrict it from -π/2 to π/2 for the domain. Y equals inverse sine of x means that the sine of y equals x. That's something that you need to pay very close attention to, because you'll notice that the y becomes the argument of the sine when it was independent on the left side, and the argument of the inverse sine is now by itself. When I say y equals sine inverse or inverse sine of x, that's the same thing as saying y is equal to the arc sine of x. Those are synonymous terms. It depends on the math book that you're dealing with. In this book, we use this notation or terminology. When you get to calculus next semester, you're going to use this notation, just because they've got two different authors. Okay? Doesn't really matter, though. All right, this is what we're looking at. Okay, here's my sine, my restricted sine. That's my inverse. Notice that the domain here is -π/2 to π/2, and the range is -1 to 1, which means that they flip for the inverse sine. The domain now goes from -1 to 1, and the range goes from -π/2 to π/2. That's important. You've got to remember that. And when you deal with that, and we graph both of them on the same axes, we'll notice that this bottom point on the inverse sine is at -1, -π/2. This bottom point on the restricted sine is exactly the opposite, -π/2, -1. And every single one of the points will do that except for which one? That one. Because x and y are both equal to 0. I mean, technically, they're different zeros, and we're switching them, but come on, 0 is 0, right? All right? Now, let's find the exact value. And this is really easy to do. If you let theta be equal to the inverse sine of x, you want to rewrite this as sine theta equals x. In other words, I'm taking the inverse sine, putting it in front of the theta as a sine, and freeing the x. And then I want to look at that restricted between -π/2 to π/2. You guys already know what these values are because you know, well, some of you know, the unit circle. Remember, degrees, always got to put the degree symbol. That's worth some points. Pay attention to your signs, and when I mean signs, I mean S-I-G-N-S, because you got to put the negatives in the right place. And I'm telling you guys right now, you got to know this, okay? Because I'm looking at this, and some of you guys did not study. I know that for a fact. This one, well, we got the degree measures right. And we got 1, 2, 3, 4, 5 radian measures correct, and then 2 points correct. That's not going to fly, guys. And I'm not saying everybody, because here's one that's a perfect 100. Nicely done, dude. Okay? You got to know it. So, if theta is -π/2, what's the sine of theta? -1, because we know this, because we know the unit circle at negative pi over 2, we're down here at the bottom, right? You got to be able to go back and forth between the unit circle and the wave. And each one of these theta values will correspond to the y values on the unit circle. So these are ordered pairs on the sine wave. Now you don't necessarily have to memorize this chart, because if you've done your homework, you already know the unit circle, so you know the ordered pairs. Okay? So we look at checkpoint number 1. It says find the exact value of sine, or inverse sine of the square root of 3 over 2. That means that I'm going to rewrite this as the fact that I'm looking at, well, let me try that again. I'm looking at theta is equal to the inverse sine of the square root of 3 over 2. Therefore, sine of theta is equal to the square root of 3 over 2. If the sine of theta is square root of 3 over 2, what's my theta going to be? Well, you should know this. Pi over 3, right? Because it's the y values going up the outside of the unit circle. Pi over 3 is equivalent to 60 degrees. If I know that's closer to 90 degrees, that means y is getting close to 1. Square root of 3 over 2. And that's going to be theta is equal to pi over 3. And that's it. That's all you got to do. As long as you know your unit circle. Now, I don't know if you guys are getting this, and some of you are doing great. And I just want everybody to understand this. This stuff all comes together on a test. And if you're doing your homework with the unit circle in front of you, without knowing it, you're going to struggle on this part. Okay? You will struggle on it. I will give you a blank unit circle on a test so that you can fill it out and use it as a reference. But that means that you got to know it, right? And if you don't know it, you can't do this. And trust me when I say you can't do this, because I'm kind of a stinker. When I give you this portion of the test, no calculators. Okay? You've got to be able to tell me what that is. There's plenty of them that you will not be able to use a calculator on. And I know what you're thinking. Come on, it's 2014, dude. Everybody's using technology. You got to understand the theory behind it, too. All right, so let's find the exact value of the inverse sine of the negative square root of 2 over 2. Well, once again, if this is equal to theta, that means that the sine of theta is equal to the negative square root of 2 over 2. Now, what's the negative square root of 2 over 2? Theta is going to be, and if you look at your table, if you don't remember it, it's negative pi over 4, right? So therefore, theta is equal to negative pi over 4. Now, how many of you guys have your calculators? Grab your calculators. Make sure you're in radian mode. That's a good question. How do you do that? Depends on the calculator. Shift mode and then type in the number 4 for that one. Okay, yeah. And you should have a little R up at the top now in the display. Make sure you're in radian mode. And then we're going to go ahead and we're going to find the inverse sine of the negative square root of 2 over 2. Which means that I'm going to hit my shift key, I'm going to hit my sine key. On my calculator, I get the display that says SIN negative 1 open parentheses. Then I'm going to hit my negative key. Then I'm going to go ahead and hit the square root of 2. Come outside, divide by 2. I could have used my fraction key if I want, which I will do that just because I feel like it now. Close parentheses and hit equals. Now, Jesse, what'd you get for an answer?
I got the estimate negative 0.78539.
Okay. Now, what does this say, though? Exact value. My calculator says negative 1 over 4 times pi. I can change it into the estimated or approximated value by pressing SD if I wanted to. Now, how many of you guys who don't have this calculator got negative pi over 4 or negative 1/4 pi? Okay, which calculator are you using? Okay, that one does the same thing as this one does, so that's cool. You didn't, right? Which, by the way, didn't I say we can't use graphing calculators on this thing, or did I? Okay. Did I? Okay, yeah, that's right. Okay, did you get an exact? Okay. Did you get an exact? Okay, which calculator are you using? You have no... Well, read it. Oh, yeah, that's a computer. That's not a calculator. The Apollo astronauts wish they had had that calculator to guide their lunar module, because that's what it can do. What'd you get? What'd you get? I'm not. Okay. Not exact. Where's your calculator, dude?
First day class, I forgot it.
Oh, sure. He always says that, you know. Did you get an exact?
No,
But you should have.
yeah, I know how to get it.
Okay. Do it again. Make sure you get the exact. Did you get an exact?
I don't know how to play it. It's not really
What did it do?
It'll be a decimal, and I don't know how to switch it to a...
Okay.
You hit the degree key, and it doesn't...
Okay. That means that you get, oh, you're in stat mode. You got to get out of stat mode, dude. Actually, I don't want to be there either. Let's go with... There we go. And inverse sine. What were we doing? Negative square root of 2 over 2, right?
Yes, sir.
Okay. There you go. And then press SD. There you go. Yeah, make sure you're not in stat mode. Okay. So, you didn't get exact, neither did you, right? Did you get exact? No. What about you? Okay. So, reason that you want to know how to do this without using a calculator, right? Unless you guys are all going to run out and pop the $17 for this one. If you know your unit circle, you can do this. It all flows, okay? All right, now, let's go ahead and talk about really what's going on here, okay? If I draw my XY coordinate system, and I look at theta equals negative pi over 4, where is that? Can't hear you guys. Yeah. It's okay. We'll go with that. It's in the fourth quadrant. It's a negative pi over 4, right? What is that equivalent to as far as a positive value? There we go. 7 pi over 4. Okay? They are both coterminal angles, right? I've got 7 pi over 4. I've got negative pi over 4. All right? Now, when I say that it is in the fourth quadrant, what I'm saying is the fact that theta exists in that interval. Okay? Theta exists in this interval. In other words, fourth quadrant angle. Okay? That's all I'm really talking about. How would I tell, or how would I establish that I want to consider an angle in the second quadrant using interval notation? Go ahead, Jesse.
Pi over 2 is less than or equal to theta, which is less than or equal to pi.
There you go. Okay, so second quadrant, quadrant 2. We're looking at pi over 2, less than or equal to theta, less than or equal to pi. Quadrant 3, we're going to go pi less than or equal to theta, less than or equal to 3 pi over 2. Technically, I shouldn't put the equals because what happens if they're actually on an axis? What kind of angle is it? What do we call it? Okay, what you were going to say something. Go ahead. I can't hear you. Quadratic? Is that what you said? You're close. It does start with a quad. Quadrantal, yes. So you're on the right track. Good job. These are quadrantal angles. So technically, I guess I should, if I want to be exactly accurate, do it like this. But hey, you know, it's close enough for government work, right? Especially our government. And then obviously quadrant 1 is going to be 0 less than theta less than pi over 2. So keep that in mind when we're dealing with these things. We can put it in interval notation. Now, actually, this is in inequality notation. What would it be in interval notation? That's interval notation, right? Interval notation. Okay. You guys get the picture what we're talking about here? Because now we're going to go ahead and talk about the inverse cosine function. And we're using the same logic. Obviously, if I look at a full-on cosine function, it's going to fail the horizontal line test, therefore not having an inverse. But if I restrict the domain on y equals cosine x, now this is different than the sine. I'm going to restrict it from 0 to pi. Okay? My range is going to be -1 to 1. When I go ahead and find the inverse, my domain goes from -1 to 1, and my range goes from 0 to pi. And it does not fail the vertical line test, so therefore it is a function. And we're going to use the same notations that we were using with the sines. Understand how these things relate to each other. Okay? I can, if I want, write it as f of x is equal to cosine of x. And if I want to write it as an inverse function, that's what it looks like, right? F inverse is equal to inverse cosine. The same concepts apply to finding exact values, except in this case, I got to know my cosine values for the unit circle. If theta is between 0 and pi, and we're going to go by, this is going to be pi over 6 or 30 degrees, pi over 4, 45 degrees, pi over 3, 60, and so on. These are my x values that are associated with that on the unit circle. So if I look at this particular problem right here, it says find the exact value of cosine or inverse cosine of -1/2. That means that this is equal to theta, and I'm trying to find the solution for cosine theta equals -1/2, which theta is 2 pi over 3. Once again, you can do that on the calculator. But not every calculator gives it to you in exact notation. And I don't want you to depend upon this. Okay? I'll ask you a quick question. How many of you guys ever worked on a construction crew? Really Did you ever use a calculator while you were out there? No, what did you do? Yeah, you wrote it out on a 2x4 if you had to, but you worked it out. You had to understand how this stuff played together. It works the same way. You got to understand how this stuff all goes together without relying on the technology. Okay? Everything you do, especially now, is hyper-dependent upon technology. But you still got to understand the underlying concepts. Scott, for example, when you go diving, do you just rely on your tank, your regulator, and everything without thinking about it? No, because what happens? Yeah, and you die. Think of it like that. Yes, I know we're in a class and you're taking a test. It's not really life or death, but at some point when you guys are out there doing whatever it is you're going to do, it could be life or death. Keep that in your head. Okay? Learn this stuff. And then there's the inverse tangent function. The inverse tangent function is so fun because we know what the tangent function looks like when we graph it, right? Or do you guys know that? Maybe you don't. Let's do that. Let's go ahead and graph a tangent function. There's an inverse tangent function. Does that pass the horizontal line test? All you got to do is look at the x-axis. No. Therefore, it doesn't have an inverse, right? But if we restrict it and go with just this part right here between negative pi over 2 and pi over 2, it will pass the horizontal line test. And we're going to be looking at the fact that we're going to do the same exact thing. Y equals inverse tangent of x means the tangent of y equals x. We're going to restrict the domain from negative pi over 2 to pi over 2. What's our range? Goes to negative infinity all the way up to positive infinity, which means when I flip this thing and I change the domain and range, the domain now is from negative infinity all the way to positive infinity for the inverse tangent function. The range is negative pi over 2 to pi over 2. And we're going to do the exact same thing. If we let theta be equal to the inverse tangent of x, that means theta is it's rewritten as tangent of theta equals x. Theta is being restricted here, negative pi over 2 to pi over 2. Will you get a value for theta that falls outside of that interval? No, you won't. If you do, what happens? You've made a mistake, yeah. Okay? Same thing goes for cosine and sine. Let's go back up and look at it for a moment. Ready to go? Yeah. Think about this. My x is going to be between negative 1 and 1, which means that if I'm trying to find an answer for this, I look at this. Theta is between 0 and pi. I won't get anything outside of that, right? So if you write down an answer and you're looking at inverse cosine and you happen to give me, oh, I don't know, 7 pi, you should know, well, that's not right. But what does that entail? That means that you know what all this says. And I know this is a lot of material. I do know this. I do understand it. Yeah, it's like that Far Side comic where the kid raises his hand, may I be excused, my brain is full. Yes, your brain is overflowing. It's going to get worse. How many of you guys have to go through Cal 3? Yeah, brains are going to start exploding, you know? How many of you guys have to take differential equations on top of that? But I promise you, once you guys get into differential equations, every single thing that you've ever been exposed to mathematically starts to really make sense. So for the rest of you, you don't get to go up there. You know, you should do it just you know, for the fun of it. Huh?
On that one, the restriction is how you know it's not pi over 3, right?
Exactly. All right? That's how we know. Okay, where was I? Oh yeah, I was right here. Finding exact values for the inverse tangent, or for tangent theta. Theta is going to be between negative pi over 3 to pi over 3. Tangent of theta will be from negative pi, square root of 3 to square root of 3. Okay. Let's look at how these things relate. We got y equals sine of x. That's the domain of the restricted function. That's the interval on which the non-restricted function's graph will have one complete period, 0 to 2 pi. Y equals cosine x, the restricted domain is 0 to pi. Once again, it has a complete period from 0 to 2 pi. Y equals tangent x, restricted domain is negative pi over 2 to pi over 2. This one has a complete period from negative pi over 2 to pi over 2, which is why it does that kind of hook, all right? The period for tangent is pi. The period for sine and cosine is 2 pi, okay? These are the graphs of the three basic inverse trig functions, which we've talked about. This is your inverse sine. It's your inverse cosine. Notice that they're flipped around, but they're not in the same location on the graph. The inverse sine is going to go from negative pi over 2 to pi over 2, whereas the inverse cosine goes from 0 to pi. And then obviously tangent shoots off to negative infinity and positive infinity. Now, these are the ones that you guys like. Use a calculator to find the value to 4 decimal places. When you're doing trig functions, generally speaking, we're going to limit our discussion, or we're going to round to 4 decimal places, generally speaking. In fact, back in the day before the advent of calculators, they used to have trig tables. They were thick and heavy, but they always went to 4 decimal places. And we're talking every angle possible, from 0 to 360 or 0 to 2 pi, okay? And then if you wanted to find something between it, like say you had a 32-degree angle, but actually let's say a 32.5-degree angle, you'd have to find the 32-degree angle, the 33-degree angle, and take the average of the two to get what you wanted. But with these things, I don't have to do that. So if I want to do decimals, you just punch it in. I'm going to go shift cosine, and I'm going to do 1/3, which is going to be 1 divided by 3. I'm going to hit enter, and I get 1.230959417. And if I go ahead and round that to 4 decimal places, well, the 5 is going to round the 9 up, which means that this is going to be 1.2310. That's what we're going to round it to. So let's go ahead and find the inverse tangent of negative 35.85. And this is equal to negative 1.5429 rounded. And technically I should be putting the approximately equal to sign in front of it. You guys remember what composition of functions is? Somebody tell me. Caitlin, what's composition of functions? I know you know because we did it. Come on, tell me. Somebody else. Sydney, what's composition of functions mean? No? Somebody tell me what composition of functions mean. Ow. Come on, am I going to have to point to everybody? Nobody? Given f of x equals, let's just say 5x squared, and g of x is equal to 3x minus 4, find f of g of x. What's that f of g of x called? Composition. Okay? In fact, everybody tell me what f of g of x is. Go ahead, write it out. Do the work. Let's see it. Okay, what do we got?
Is that 3x minus 4?
Yeah, it's a 3x minus 4. Okay. What'd you get for an answer?
45x.
Okay. I have no idea. So that means we're looking for f of 3x minus 4, which means we're looking at 5 times 3x minus 4 quantity squared, which means we're looking at 5 times 9x squared minus 24x plus 16, which means we're looking at 45x squared minus 120x plus, it is 120, right? Yeah. 80. Is that what you said? Yeah, it's plus 80. Why? Because you take 3x minus 4 and FOIL it, negative 4 times negative 4 is a positive 16. Remember, this is in the form of a minus b squared. A minus b quantity squared is equal to a squared minus 2ab plus b squared. Right? Okay. All right, so cool. You guys can do that. Awesome. Let's do this. Given f of x equals x squared minus 3, find f, we're not there yet, find f inverse of x. Okay, given a function, you want to rewrite it as y equals x squared minus 3. And then you want to invert the y and the x, right? This is x is equal to y squared minus 3. And then you want to solve for y, which means that I'm going to add 3 to both sides of this thing. X plus 3 is equal to y squared. Take the square root of both sides and get y is equal to the square root of x plus 3. And then rewrite it as f inverse of x is equal to the square root of x plus 3. Remember that? Do you remember that? Because you're looking awful puzzled. Okay, quick show of hands. How many of you took Math 112 here at this school? How many of you took, well, I meant Calhoun in general. How many of you took it this summer? How many of you took it in the spring? Did anybody take it in the fall? Okay, word to the wise, never skip that many semesters between classes ever again, because you forget things. Did you take pre-calculus algebra? How many of you have not had pre-calculus algebra at the collegiate level? Okay. Now, of all of you guys, how many of you remember actually seeing something like this at some point in the past? Okay. Do you sort of remember how to do it now? Okay, because it's an important concept. Because you're going to, what's the matter? Finding the inverse? Yeah, you should have done it at the same time that you were learning about compositions. And if your instructor, and you know, instructors all the time skip stuff. I've skipped a couple of things here, but they're not what I consider to be damaging down the road. Some instructors will skip stuff and it will be damaging down the road. Yes? Yeah. Yeah. This is one of those things they shouldn't have skipped, though. Yeah. Well, it was the summer, man. Seriously, you wanted to be outside with the bee, you know, having fun. I understand. What I suggest you do is go back in your textbook. Who's got their textbook with them? Anybody? Actually, I want to go way back. I forget where it is. It's in chapter 2, I believe. No, actually, it's in chapter 1. What section is that? That's 1-6. Yeah, section 1-7. Composition of functions. And, well, actually, section 1-8 is inverse functions, which is going to be page 2, starts on page 245. Yeah, exactly. I would suggest you go back and look at that. And even if you don't have a textbook, it's in my math lab. You can look at it. Oops, wrong chapter. Look at that, inverse functions. And that's going to tell you how to do them. If you don't remember, I would definitely review that. Okay, now, back to what we were talking about. How do we verify that f of x equals x squared minus 3 and f inverse of x is equal to the square root of x plus 3? How would you verify that? Say that again? No, not in this case. I know what you're thinking. You're thinking about even and odd. Yeah, that's okay. Jesse?
Plug in a value for f of x and then plug in whatever answer you got into f negative of x, and you should arrive back at your original value.
Okay. And that'll work. But what if I don't want to pick a value? What if I want to verify this for all values of x? Because I'm a stinker. Because there are functions out there that you can plug in a value, get a value, plug that value into another function and get the original value back, but they're not inverse functions. So instead, I want to do this. I want to verify that f of f inverse of x is equal to x, and that f inverse of f of x is also equal to x. Which means I'm doing what? Composition of functions, right? So, if, and I know that we've forgotten what f of x is, but f of x is equal to x squared minus 3, and we determine that f inverse of x is equal to the square root of x plus 3, I want this side of the room to do f of f inverse, and I want this side of the room to do f inverse of f. Don't you hate it when the math teacher makes you do math in class? Come on, everybody's pen and their pencil should be moving. Even if you don't want it to. It's good for the brain. So, yeah, we're verifying f of f inverse of x being equal to x. So do the composition, f of f inverse. And then on that side, you're doing f inverse of f. While you're doing this, quick question to contemplate. Do you enjoy doing problems in class? Or would you rather I just lecture at light speed? Okay. That's one person. Two. Yeah? Thank you. That's what I've been trying to tell my colleagues across the nation. I seem to be in a distinct minority when it comes to thinking that by doing stuff in class, you guys come away with a better understanding of it. Instead of just sitting there and just rattling this stuff off, I want you guys to understand it. I want you to be able to use it. That has been going on since Socrates and Plato were teaching people. So, okay. You want to be involved. Let's see. I don't know names yet. I'm still working on it. What was your name again? Anthony. What do you got for an answer? Did you get X? Okay. Now, it's at this point that you guys lie. Say, yeah, I got X. Did you get X? Everybody get X on this side? All right, where'd you go wrong? What? Completely lost. Okay, cool. I mean, not cool, but now I understand why, okay. Where is it that, okay, let me ask you this. When I say find the composition, and this goes for everybody, what's going through your head? I'm taking two functions. I'm going to take one of those functions and I'm going to cram it down the throat of the other function. That's really all I'm doing. Okay? And what's going to happen is it's going to come out the other end as something different. So when I say, for example, let's look at this one right here. Okay? This is saying f inverse of f of x. What I'm telling you to do is take this f inverse of x, and it is equal to the square root of x plus 3. Okay? And then I say, okay, I want you to find, no, wrong color. I want you to find f inverse of, and then I'm going to use dark blue to represent f of x. Nope, wrong. But what is f of x? Well, f of x is this x squared minus 3. So that means that I'm looking at finding f inverse of x squared minus 3. Remember, whatever's in the parentheses here is going to go back into my function wherever I see x. So I take this x minus 3, and I'm going to cram it down the throat of this one. So this whole thing is now going to be equal to the square root of. And then the x becomes x squared minus 3 plus 3. And now I simplify. Negative 3 plus 3 is 0, and I'm left with the square root of the square root of x squared, which is going to be x. So this and that go away. I'm left with the square root of x squared, which we all know is equal to x. Does that help? Does that help everybody who's unsure of this? And then for f of f inverse of x, I'm going to take the square root of x plus 3 and cram it in here, which means that when I square it, I get x plus 3, and x plus 3 minus 3 is x. Okay? Now, we understand. So let's talk about the inverse properties of the trig functions. There's a little bit of a caveat to this, though. You have to understand what the restriction is on your function. And since we're going ahead and understanding that our sine function in its inverse is being restricted on its domain, that means the inverse functions are going to have to be, you have to pay very careful attention to when you do a composition. The sine of the inverse sine of x will be equal to x for every x in the domain or the interval negative 1 to 1. In other words, x cannot be less than negative 1 and x cannot be greater than 1. The inverse sine of x will be equal to x between negative pi over 2 and pi over 2. You can't, and you won't be able to take the inverse sine of the sine. Okay? Likewise for cosine. Notice that the interval here for cosine of inverse cosine is the same thing as sine of inverse sine, but the interval for inverse cosine of cosine is different than inverse sine of sine. Instead of being negative pi over 2 to pi over 2, it's 0 to pi. Tangent. I can take the tangent of the inverse tangent all day long. There is no restriction because it goes from negative infinity to infinity. But the inverse tangent of tangent is also restricted to negative pi over 2 to pi over 2, just like the sine. You got to know this in order to be able to do the problem. However, there are tricks because I can use the principles of coterminal angles, reference angles, and cofunctions to get around some of this. This is where this is going to mess you up. Because I'm going to give you a problem. It's like this, and we're going to talk about it. You're going to pop to your calculator, and it's going to tell you undefined. And you're going to write that down on the test. And I'm going to mark it so wrong, it will hemorrhage red ink. Okay? Because there are ways to do this. All right, so we want to find the exact value, if possible, of those following composition of functions. Now, the thing is when I look at these, let's look at the first one, the cosine of the inverse cosine of 0.7. This right here is my x value, correct? And if we go back up and look at our cosine, when I'm looking at the cosine of the inverse cosine of x, x has to be what? Between negative 1 and 1. Is 0.7 between negative 1 and 1? Sure it is. So what's the answer to that going to be? 0.7. Okay? Now let's look at the next one, the inverse sine of the sine of pi. Now, let me scroll back up a little bit, because when we look at this one, we're looking at this right here, and we're looking at the fact that my interval goes from negative pi over 2 to pi over 2. So when I do this, I look at my function, and I look at this. That's my x. Does pi fall between negative pi over 2 and pi? Yes, it does. Think about it, guys. On the unit circle, let's talk about it for a moment. If this is negative pi over 2, and this is pi over 2, it does fall between that if I'm going this way. Am I going that way? No. I'm going that way. So does it fall? Okay, but let me ask you a quick question. What's the sine of pi? The sine of pi is 0. Okay, so this right here, this whole thing, sine of pi, is equal to 0, which means that I'm doing what? I'm trying to find the inverse sine of 0, correct? Now, what's the inverse sine of 0 going to be equal to? Well, if we remember our definition, the inverse sine of 0 is equal to my theta, right? Which means that this whole thing means that the sine of theta is equal to 0. What theta do I have that gives me a sine that's equal to 0? Yeah. 0 and pi. So therefore, what's the inverse sine of the sine of pi? It's equal to 0. And why do I know it's equal to 0? Because this value right here, that most definitely falls between negative pi over 2 to pi over 2. Right? So therefore, theta is equal to 0, so this whole thing is equal to 0. Plug that into your calculator. Tell me what you get for an answer. I'm just curious. And we'll go with radian measurement. Okay? So we'll go ahead, we'll do shift, sine, then do sine, and then we'll do pi, close parentheses twice, and it gives me 0. What'd you get, Jesse? 0. Got 0. Anybody get anything other than 0? Okay. The calculator, as we put this in here, understood that the value that I'm looking for is not going to be found in the standard mode. As this is written, it's not possible to simply say pi, right? Because that's what you would be thinking it should be equal to. Because the inverse undoes the regular function. That's what you're used to. F of F inverse, they undo each other. In F inverse of F, they undo each other. That's not what happens here. So when we look at this, the sine inverse of the sine of pi is not possible as written, because it is not equal to pi. Okay, does that make sense? I have to go ahead, find out what the sine of pi is first, and then find out what the inverse sine of that is. Because if I go back up here, does pi fall between negative pi over 2 and pi over 2. No, it doesn't. And I guarantee on the test, when you have to find the exact value and you're not using a calculator for those, somebody's going to write pi because they don't know everything they need to know about this. Does that make sense? Okay. So let's go ahead and find the cosine of the inverse cosine of negative 1.2. You guys tell me what you think that is. Yes. Why is it undefined, Jesse?
Because negative 1.2 does not fall in the range available for our.
And I said that when we were first talking about it, right? I said if it is less than negative 1 or greater than 1, I just told you to shut up. I can't find it. Try it on your calculator, see what you get. You get an error. Okay? And it depends on the calculator. It'll tell you undefined, error, go to, I don't know, whatever. Okay? So this one's undefined. But did I need a calculator for it? No. Okay. Why is that there? Oh, okay, I know why I put that there. Just so that I can give that. Remember that the inverse sine of 0 equals x is the same thing as the sine of x equals 0. And we also know that the inverse sine of 0 is equal to 0, which we already talked about. And we're going to use the fact that y equals sine x equals x, or is the same as x equals the inverse sine of y. And we're going to use that for both the cosine and the tangent function also. Let's go ahead and find the exact value of the cosine of the inverse tangent of 5 over 12. Go ahead, put it in your calculator. Let's see what we get. We got the cosine. Of course we're in radians. What'd you get, Jesse? Okay. What'd you get? Okay. As him? Or as him? Okay. What'd you get? What'd you get? What'd you get? Yeah, because you can go backwards, right? You guys know how to use your fraction and decimal key on your calculator? What happens when you try that? What'd you get? 12 over 13. Now, if you know how to use your fraction and decimal key, you can do it. However, being the stinker that I am, I'm going to write on this, show your work. Which means I want to see what you're doing. Because, once again, do you understand what the cosine of the inverse tangent of 5 over 12 is actually asking you to do? It's a rhetorical question. You don't have to answer it, because I know most of you probably don't. Why? Because you haven't been given that information yet. But when I say find the exact value, and we are almost out of time, so I will just state this, and then we'll finish this one on Thursday, and then we'll crank out 4.8. We will have a test a week from Thursday, okay? I know that's probably not what's in the schedule, but oh well. When I'm looking at this, I'm going to use right triangle trigonometry to help me understand what this thing is. I'm going to visualize it. Because when I'm using a composition of functions, I'm trying to understand what the hypotenuse and the x and the y legs are, or I'm trying to understand what the radius of the unit circle is versus, and it doesn't have to be a unit circle, it could be anything, versus the x, y coordinates. And we're going to use this to solve problems. Okay? All right, I'll see you guys on Thursday.